Welcome to qnawire.
Okay, this is a fun one. We want to design a DC transmission line that can transmit 225 megawatts of electricity. And we need to do this over 185 kilometers with only 2% loss. We know that the wires need to be made of aluminum and that the voltage is 660 kilovolts. So the first thing that we should figure out is how much power is going to be lost. So the power lost, we want to be equal to 0.02 or 2% of the total power. And we know that the current is going to go like the power output over the voltage. And so the last thing we need to know before we start is that the resistance of our line will go like the resistivity of aluminum times the length of the wire, which is going to be 185 kilometers, over the area, where the area, of course, is just going to be pi r squared, or d over 2 squared. So now, using the fact that the power lost is given by the current squared times the resistance of the wire, plugging in for I and R, we find that this is equal to 4 times the total power times the resistivity and the length of the wire over pi d squared v squared, voltage squared. So now we want to solve for d. Since the material is given, we want to find the diameter of wire to use. And so solving for d, we find the expression 8 times the total power output times the resistivity and length for pi times the fraction of power that is going to be lost, 0.02, times the voltage squared. And all this to the 1/2. So now we simply need to plug in values. So we can look up the resistivity of aluminum, we know the total power output, we know the length, and we know the fraction of power loss of the total power. And this works out to be 1.8 centimeters in diameter. So our wire needs to be 1.8 centimeters in diameter in order to have only 2% losses, transmitting 225 megawatts of electricity over 185 kilometers.